Hello everybody. Okay, so in this video we're looking at two-way tables and calculating probability. So what is probability? Probability is the study of chance. We want to find out how likely it would be for something to happen. So probability goes on a scale from 0 to right? One meaning it's certainly going to happen. Zero meaning it's impossible. It's not going to happen. And we usually dictate probability by like fractions or like decimals. So, for example, a coin toss has a half chance of being ahead, right? Or a 50-50 chance of being ahead. So, last video we was looking at calculating how many outcomes two events has. This video we're going to be looking at, well, how can we systematically write all of these outcomes? So first we need to know is the list of all possible outcomes is called a sample space. And in first year we look at something called a two-way table, right? So a two-way table is what we see down here. Then if we want to calculate the probability of something happening, so if we look over here, P bracket E, that just means the probability of an event E happening. And how we do that is the probability of an event happening is the number of favorable outcomes, i.e. the outcomes we want, over the total number of outcomes. So, have a go here. So John flips a coin and rolls a dice. Use a two-way table to show all the possible results. So down here we have the outcomes from a coin toss. And then across here we have the outcomes from a dice toss. So he could get a heads and a 1, heads and a 2, he could get a heads and a 3, he could get heads and a 4, get heads and a 5, and a 6. Or he could also get tails and a 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, and a tails and a 6. So what is the probability that John gets a head or an even number? So he gets a head, grand. He gets them or an even number. Well, he gets a 2 here, and he gets a 4 here, and he gets a 6 here. So this would be him getting a head or an even number. So it's very important to note, or means we are happy if either one thing happens, or the other, or both. We count all the outcomes that match that condition. And on the other hand, means them two things have to happen together. So what if he wants a head and an even number? So we can only we are strict with them conditions. So what is the chance that John gets a head or an even number? So the probability of heads or even. How many outcomes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 outcomes out of a possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 9 12ths. 9 12ths simplifies to 3 quarters. So there's a 3 in 4 chance of getting a heads or even. What is the chance that John gets a tails and a prime number? So we're looking for a tails and a prime number. So I here to a pink. So tails and a prime. A 1 is not a prime number. Not counting that. 2 and a prime, counting that one. 2 is a prime, 3 is a prime, and 5 is a prime. We only have 3 outcomes here. Probability of the tails and the prime number. So they both have to happen here. That is going to be 3 over 12, which that is how right? We'll do a few questions here. Thomas has 9 tiles, each letter on it. So SIN, COS, DAN, sine, cos, tan. Right? He calculates, he picks a tile at random. Write down the probability that he's chosen the letter S. So we want the letter S. We have 1, 2, 2 with the letter S. So the probability getting S is equal to 2 over 1, 2, 3, 4, 5, 6, 9. 2 and 9. Next one, we want the probability of getting an N. Again, we only have 2 outcomes with an N, so the probability of getting a N is 2 in. Probability of not getting the letter O, so not the letter O, so it's 1, 2, 3, 4, 5, 6, 8. So not O be 8/9. Then the letter A or C. So he has one C, one A. So probability of A or C, 2. Right, the following terms can be used to describe the probability that an event happens: likely, certain, unlikely, and possible, 50-50. For each event in the table, which of these terms describes the probability of happening? So when a fair coin is tossed and you get heads, well, that's just 50-50, a 50-50 chance. If you buy a lottery ticket for Saturday's draw, you will win the jackpot. So it's unlikely, right? It's not impossible. You could win the lottery. You probably won't, but you could. And then the 1st of January would be New Year's Day. Well, that's certain, right? The New Year's Day always falls on the 1st of January. And 4 events here, A, B, C, and D, are picked below. You pick a red ball. So we need to plot these on the table below. So you pick a red ball from a bag containing 3 black and 7 red balls. That seems very likely. I think that's here. You get a natural number less than 7 when you roll a regular 6-sided die. That's certain because we have to get a number greater less than 7. It's 1, 2, 3, 4, 5, 4, 6. You pick a red card from a deck of playing cards. That is an even chance because of even chance of getting a black or red card. And then finally, you pick a yellow ball from a bag containing 4 red balls and 2 white balls. Well, that's just impossible because there's no yellow balls in the bag. Have a look at this one now. An experiment consists of throwing 2 fair standard 6-sided die and record the sum of the 2 numbers thrown. Some of the totals are shown in the table. No, they're not. So we're adding these together. So the sum of the 2 numbers. So 1 plus 1 is 2, 3, 4, 5, 7. 2 plus 1 is 3, 2 plus 4, 2 plus 3 is 5, 6, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 10, 6, 8, 7, and here 6 plus 1 is 7, 8, 6 plus 3 is 9, 6 plus 4 is 7, and 6 plus 6 is 12. Find the probability of getting 7 or 11. So we have 1, 2, 3, 4, 6, 7, 8. So we have 8 in how many chance? 36 chance of getting a 7 or an 11. Probability of 7 or 11 is going to be 8 in the 1, 2, 3, 4, 5, 6, 12, 18, 24, 30, 36. 8 and 36. That is equal to. Find the probability of getting a total, which is a prime number. So a prime number would be 2, 3, 5, 7, and 11. So remember, a prime number is a number whose only factors are 1 and itself. So 1 is not a prime number, but 2 is a prime number. 2 is the only even prime number. So I need to get any of them. So I have 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14, 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13. That'll be 15, 36. Last one here. Maria is playing a game. She rolls the dice and spin a spinner. Complete the table below. So we're listing all the outcomes here. So she can get a 1 and an A, a 1 and a B, or a 1 and a C. Get a 2 and an A, 2 and a B, 2 and a C. Get 3 and an A, 3 and a B, or 3 and a C. 4 and an A, 4 and a B, 4 and a C. Get a 5 and an A, 5 and a B, 5 and a C, or 6 and an A, 6 and a B, 6 and a C. How many different possible outcomes are there in total? Well, there are 6 times 3, so 18 possible outcomes. And then finally, List all of the outcomes that have an even number and b. Even number and b. So that's just going to be 1, 2, 3. There's only 3 of them. So that's just 2b, 2b, 4b, and b. Each outcome in the table is equally likely. Calculate the probability that Maria will get an even number and a b. That is just even and b. We have 3 favorable outcomes over 18 total outcomes. The answer is 1/6. So she has a 1 in 6 chance of getting an even number and a b. And that's it for this video. I hope it was some help to you guys, and I'll catch you guys later. Bye.